Algebra 2, simultaneous equations, type 1, linear equations with two variables. So when we're doing simultaneous equations with two variables, essentially what we're doing is we're finding the point of intersection of two lines. In other words, we're going to solve for the value of x and for the value of y. For example, if we're given two linear equations, 3x plus 2y equals 21, and 4x minus 5y equals 28, and we're asked to solve the simultaneous equations, then what we're trying to do is find the value of x and find the value of y. So the first thing we want to do is always number our equations. So we're going to number them 1 and 2. And then we need to decide which letter are we going to eliminate first, x or y. It doesn't matter which we choose because it'll all end up being the same answer. So I'm going to choose to eliminate the y because I can see one is positive and one is negative. So this is going to make my life a little bit easier. And I need to make sure that the coefficients are the same in order for me to eliminate y. So I'm going to multiply the first equation by 5, and I'm going to multiply the second equation by 2, because what that's going to do is it's going to make my y 10y in both equations. But one will be positive 10y and the other will be a negative 10y. But I'm not just multiplying the y by 5, I have to multiply everything in the first line by 5. So what I do to the left, I must do to the right. So that gives me 15x plus 10y equals 105. And in the second equation, I'm going to multiply everything by 2, which gives me 8x minus 10y equals 56. So if I draw a line underneath it, what I'm essentially doing next is I'm going to add the x terms, add the y terms, and add the constants. In other words, I'm adding my like terms. So 15x and 8x is 23x, 10y minus 10y is 0, and 105 plus 56 is 161. So now I have just to get x on its own, so I'll divide both sides across by 23, which gives me x has a value of 7. Now I know what x is, I can then sub it back into either equation 1 or 2, and again it doesn't matter which one I choose. So I'm going to sub x into equation 1. So that's 3 times x, and x is 7, plus 2y equals 21. So 3 times 7 is 21. So if I subtract 21 from both sides, I get 2y is equal to 0, and therefore y is equal to 0. So if we were looking at coordinate geometry of the line, we would therefore say that the point of intersection of the lines is 7, 0. This is not necessary if you're doing an algebra question where you're just asked to find the values of x and y. We would just keep it as x equals 7 and y equals 0. Sometimes we have fractions in the equations that we're given, so we want to make life easier for ourselves and eliminate the fractions. So I'm going to multiply the first equation here by the lowest common denominator, which is 15. And if I multiply the second equation by 18, well, that'll eliminate the fractions. So in the first case, I'm multiplying 15 by 2 over 3x, and 15 times 3 over 5y, and 15 by 8 over 5. So I can see, well, 3 goes into 15 5 times, 5 goes into 15 3 times, and 5 goes into 15 3 times. So that gives me 5 times 2, which is 10x, 3 times 3, which is 9y, and 3 times 8, which is 24. So now we have a nicer looking equation. So if I do the same then to the second equation, I'm multiplying 18 by a half x, and 18 times 2 over 9y, and that's equal to 18 times 17 over 18. So to simplify, well, 2 goes into 18 9 times, 9 goes into 18 twice, and 18 goes into 18 once, which then leaves me with 9x plus 4y is equal to 17. So now it's like the previous example where we have two nice equations to work with. And we decide, do we want to get rid of the x's or do we want to get rid of the y's? So let's line them up so we can have a better look at them. So if I choose to get rid of the x's, that means I would have to multiply the first one by 9 and the second one by minus 10. If I want to get rid of the y's, I would have to multiply the first one by 4 and the second one by minus 9. So in other words, we again are trying to make the coefficients the same but opposite in sign. So I'm going to get rid of the x's. So I'm going to multiply the first one by 9 and the second one by minus 10. So that gives me 90x plus 81y is equal to 216. And the second equation becomes minus 90x minus 40y is equal to minus 170. So adding my like terms, I'm left with 0x. 81y minus 40y gives me 41y. 216 minus 170 gives me 46. And if I divide across by 41, it won't simplify. So I'm left with a fraction answer. And that's okay. That happens sometimes in our questions. So we then repeat by getting y and subbing it into either 1 or 2. Again, it doesn't matter which one. And we try and solve for x. So we have 10x plus 9 times 46 over 41 is equal to 24. And that gives me, if I multiply everything across by 41, I can get 41 times 10 is 410x. 41 times 9 times 46 over 41 gives me 414. And 41 times 24 is 984. So bringing 414 to the right-hand side, so subtracting 414 from both sides, I get 410 equals 570, and therefore x is equal to 57 over 41. So if we summarise our steps, what are we doing? So we start by numbering our equations 1 and 2. We decide on the variable that we want to eliminate, such as x. We multiply both equations by a constant to make the coefficients of, say, x, for instance, the same but opposite in sign. We're going to then add our equations, which will eliminate the variable you chose, such as x, and then you solve for the remaining variable, i.e. y. We would then sub the value for y back into 1 or 2, and then solve for the second variable, which in this case would be x. You can also check your answers by subbing both x and y back into either 1 or 2, and you should get the left-hand side equals the right-hand side. This is not compulsory, but sometimes it gives you peace of mind that you have the correct answers. So if you go to page 31 in your books, and you're going to do question 5, 6, 8, and 11.